Here is another example of the integral test. So let's look for our function f. 1 over the square root of e to the 2x minus 1. You notice that my function is almost the same as the series. The only difference is the variable. To make sure that a sub n is really equal to f of n. Okay? So first question, is this positive? Well, the numerator is positive 1. The denominator is positive square root. The quotient of two positive numbers is a positive number. Is it continuous? Since x will begin at 1, the only way the denominator can be 0 is when x is 0. So because x is 1, then this will never be 0 in the denominator, for x is greater than or equal to 1, and so the function is continuous. Is it decreasing? Well, we know that a fraction is getting smaller the bigger the denominator is. So I'm looking at the fraction 1 over 2x e to the 2x minus 1 compared to 1 over e to the power 2x plus 1 minus 1. You notice that this is a bigger exponent than here, so naturally this will be smaller. And so we know that the function is decreasing. So all we need to do now is do the integral test. 1 to infinity of 1 over the square root of e to the 2x minus 1 dx. What I'm going to do is, again, replace infinity by some variable b and apply the limit. And so we get 1 to b of 1 over the square root of e to the 2x minus 1 dx. This appears that we can rewrite this as in the form of arcsecant. If u is e to the x, then du is e to the x dx, right? And a is equal to 1. So what we will do is introduce e to the x in the numerator and e to the x in the denominator. So I'm not changing the value of the integral, I'm simply rewriting it so that it will take the form of the arcsecant. And so here we go. We have the limit as b approaches infinity of arcsecant u over a, which is e to the 2x over 1. We will evaluate this from 1 to b. So evaluating this expression, as x goes from 1 to b, we get arcsecant of e to the b. This should be x, not 2x, because our u is x. Then this should be x only. So e to the b minus arcsecant of e. Well, if you recall, the graph of the arcsecant function is asymptotic at pi over 2. Arcsecant 0 is 1 and it goes to infinity. As it goes to infinity, it approaches pi over 2. So applying the limit here, as b goes to infinity, then this becomes arcsecant of infinity, which is equal to pi over 2 minus arcsecant e. So that is our answer. Because the improper integral is convergent, then the series is convergent.